As you can see, I've copied the survey notes here just for reference. This does not need to be or should not be included on the cross section. However, just for training purposes, I added it there to show that when laying out the cross section or profile, how I like to go about doing it is starting out with number one, knowing that 2 of these blocks equals 1 inch. Once this PDF is printed or plotted out to scale. So that's 1 inch there, 1 inch there, and you can see same thing lines up with our horizontal and vertical scales up here. So what I like to do is figure out exactly how much of this sheet that we need to successfully plot our cross section. Keep in mind, this is provided to the contractor, so it is important that it is legible, easy to read, easy to interpret, and not scrunched up enough where it's hard to see any details. We want to make it as large as possible, really, to pick up on any details that will be shown in the cross section. So here we have about 28 half-inch grid blocks, ends up being 14 1-inch grid blocks across the horizontal axes. And then we have about 9 1-inch grid blocks up the vertical axis. So what I've done here is figured that we need at least 92 feet horizontal going from -50 to 42. So we need at least 92 foot of horizontal along the bottom. And then for the vertical axis, we need at least 4 feet of vertical going from 522 down to our lowest elevation at the center line of the stream at 518.52. So that gives us 4 feet. Another tip, obviously I can't show you here on the computer with a PDF, but when you're hand plotting this on the desk with a pen and paper, highly recommend using an engineering scale to help plot your points. It goes a lot easier the way that you can line up your elevations and stationing with your scale. So scrolling on down, I rounded that 4 up to 6 just because it is good to have a little extra room vertically. Because if you remember from the training, it's always good to have the bottom of your stream crossing, if you're doing any in-stream stabilization, whether it's gravel or slats, that is about 2/10 below the existing stream bed elevation. So want to leave a little bit of room. And then for our horizontal scale, I picked maybe a 10 scale would work here. So 92 feet divided by 10 is 9.2. And then I rounded that up to 10, which means we will need 10 1-inch grid blocks. And to show you all what that looks like here, we have our 50 over here, or -50 on the left looking upstream. We'll only need out to 42 according to our survey. So I went out to 45, 50 just to make it even. And then for our vertical scale back here, I divided that vertical by 2. So therefore, 1 inch equals 2 feet. As you can see, so down here we have 1 inch equals 10 feet, 0 to 10, and then 519 to 521 is 2 feet for our 2 blocks, which equals 1 inch. So once that scale has been determined, you can go ahead and start plotting your points. As you can see here, we had already got started with this. -50, we've got 521.4, and it's okay to just round these to the nearest tenth of a foot. If you zoom in here, I started out -50, 521.4. So here we have our -50 line coming up here. Now, if this, on this scale, we have 520, 521, which would mean each of these gray lines is going to equal 2/10. So that lands us right here on 521.4. Right there. Next point, 521.3. Again, on this scale that I've selected here, knock that one down a little bit. 521.3 at station -45. So we have 2, 4, and right in between there is going to be 0.3. Next one is -26. So here on this scale of 1 inch equals 10 feet horizontal, this worked out nice for this survey and cross section because each of these lines is going to be 1 foot. So at 26, we jump over to this line right here. That's 26, and then our elevation was 520.7 right there at -26. Then we'll go to the next one, -10, 520.9. This is where the engineer scale comes in handy. But instead, I'm using these green lines here to show how I'm plotting these points. So again, that was horizontal station -10 and a vertical elevation of 520.9 puts us right there. And as you can see, I've filled in the blanks here on our horizontal and vertical scale. So once I've finished plotting all of the points, it is then time to start connecting those points to show our existing ground line. So now that we've got our existing ground line plotted, it's now time to start. So now that we've got our existing ground line plotted, it is now time to start analyzing this cross section and seeing what slopes the approaches should be installed at or could be installed at, and how wide we want the crossing. Now, to do that, there's two main things to consider, one of which being our slope should not exceed 6-1. 5-1 is still okay depending on the type of crossing. However, the flatter the better, just for animal safety, walking up those slats or gravel and being able to get their footing without slipping and injuring themselves. So it's not always easy to get slopes of the approaches flatter than 6-1, because as you can see here, this channel is heavily incised. So we're going to see what we can do with getting these slopes as flat as possible. Another thing to consider is we do not want to install the crossing like this, where it would potentially, or where it would encroach on the stream channel, existing stream channel. Ugh. Another thing to consider while designing and drawing the cross section to determine our slopes and extents of the crossing, quantities and whatnot, is that we do not want to the other thing to consider when plotting your crossing on the cross section is that we don't want these approaches to come in and encroach on the existing stream channel cross section, or don't want to put this stream crossing in and choke off the stream any more than it already is. So we want to make sure that these are back outside of, whoops, the existing stream channel. And as I mentioned in the training and before, we want the bottom of this crossing to be 2/10 below the stream bed elevation. So here we have 1/10, 2/10. And then we'll see how far out we need to go to get an even number here, divisible by 4, seeing as the precast concrete slats come in either 4x10 or 4x12. In this design, slats were used so let's take my measuring tool, set it to my scale of 1 inch equals 10 feet. Right there. want that to be 12, which would mean 3 slats in the channel. Since those slats are 4 foot wide. Next, we will take our design storm elevation or bank full as shown here on the spreadsheet. That is 2 feet. So from here, existing stream bed was at 518.5 plus 2 is going to give us 20.5. Right there. And as a reminder, that is where we want to take our slats in this case and our framestone up to. Or if you were doing a gravel approach, that would be where you would want to bring the framestone up to. Now that we have the design storm elevation, we can start to determine how many slats, how far up we need to go with those slats in the framestone. All right, so I will start by measuring 15, 16. Again, a number that's divisible by 4. See if that gets us a reasonable slope from the stream channel slats up to our design storm. Looks pretty steep due to the exaggerated scale. However, when we factor in these elevations and the scale that is on, we have 18.5 here. Minus 2/10. So our slat's going to be at 518.3. And then our design storm elevation was 520.5. Just to double check that again, right there in between 520 and 521, got 520.5. So then to calculate the slope of this line or proposed slats, I'm going to do rise over run. Again, our rise or elevation is 2 feet from 518.5 to 520.5. So that is 12.5%. That is a 8-to-1 slope. So that is good to go. It's flatter than 6-to-1. Now this side might be a little bit more challenging. There's a higher bank, and if you could tell in that photo, this was a little bit of a difficult site, being that there's a walkway that takes a hard left turn there, another walkway that goes out to a pasture. This area all up here was wetland, so we could not encroach on that area outside of the fence. So this side had to be a lot steeper to get it to fit in that small area. So we'll check to see what our distance is here. Right about 12 feet. And again, we're going up 2 feet to our design storm elevation. So we'll go 2 divided by 12 equals 16.6% slope, which also equates to a 1-to-6. So that works well there. So now that we've determined that it will take 4 slats to get up to our design storm elevation on an 8-to-1 slope on that side, and it'll take 3 slats to get up to our design storm elevation on the right hand side looking upstream. We can go ahead and start drafting our cross section. These slats are typically just for livestock and small tractors equipment. All you really need is a 5-inch thick slat. If this was for large equipment, say a combine, you'll want to use 8-inch thick slats, but I'm going to go ahead and, 5 inches divided by 12 inches per foot equals about 4/10. So we will go from 518.3, 1, 2, 3, 4 to 517.9. That's going to be the bottom of the slat. And then I'm going to take this and go up 4 feet. 1, 2, 3, 4 for a 4-foot wide slat. Then another 4 feet for our second one going up the bank. Then another 4 feet for the third. And another 4 feet for the fourth. And then we'll go 4, one, two, three, three slats in the channel, and then same thing here. Copy that little 5-inch long line. Go 4 feet. And then go another 4 feet. And since we didn't have a lot of room to work with over here, we just went up 3 slats. I realize this is a bit under the design storm elevation. If there were more room to run slats up the bank before we got to that fence line, I may have gone one more slat just to be safe. But in this case, if we're just a couple tenths below, it's not the end of the world, but we want to get as close to that design storm elevation as possible. Maybe bring the frame stone up a little bit further as it ties in with the gravel walkway up there, but we'll go and finish drawing in these slats. And then per our slatted crossing detail, we have a minimum 4 inches of number 57s underneath that. So 4 inches. Divided by 12, it's 0.3. Actually, I'm going to pick a different color for the stone. We got 3/10, 3/10. And one. And then connect those points to show our gravel base beneath the slats. Then we can draw in our fabric that goes underneath of that. And there's our crossing, but we have a little bit of a problem because we need to get these cows out to where they need to go on the walkway and their pasture. So from then on, we need to draw in our walkway. I will use the purple again for stone. And let's take that out 10, 15, 20, 25, 24. Let's take that out 24 feet. Back to existing ground. And then same thing over here. Not going to be as easy. We will just hold this 6-to-1 slope. So we did not have a lot of room to work with there. And just go about 12 feet, 11 feet. Right there. Up to existing. And then that slope will remain at 6-to-1. And this will flatten out after the 8-to-1 gets up to our design storm elevation. So we'll go ahead and finish drawing in the animal walkway approaches. Got 8 inches plus 3, 2RC plus the optional 2 inches. So let's shoot for 8 inches of toe number 3s and 4 inches of 2A. That'll give us an even 1 foot total to draw in here. So we have 1 inch equals 2 feet. So half an inch is going to be 1 foot. So if we go 1, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 1. There's our gravel animal walkway. And the bottom, and then we will draw in our fabric. And then once we're done drafting in the crossing and the walkways, it's good practice to label. Our black line again is existing ground. Maybe we could say existing fence over there. And we have 4 foot long, 10 foot wide, pre-concrete slats. Left looking upstream. Right looking upstream. Just to help orient ourselves, the contractor. And then we'll call out our animal walkways. Set again. Twelve. We got 3 4 foot long by 10 foot wide precast concrete flat. And we can copy that too. So we got 3 on the right looking upstream. All right, and there we have it. Our cross section for the stream crossing.